Hello, everyone, and welcome to Indoor Biotechnologies' latest webinar on the environmental testing suite and viral testing capabilities, where we're going to discuss the use in product development and validation testing. We'll be providing an in-depth discussion of InBio's unique product testing capabilities today. We really appreciate you taking time out of your busy schedules to join us, and are really looking forward to presenting this information to you. We've got a great lineup of speakers today, all of whom are from our sister company, Indoor Biotechnologies Limited, located in Cardiff, Wales. We'll be starting with Dr. Hayley Mills, who is our European business manager at Indoor Biotechnologies Limited. Hayley's going to be providing a product testing overview of Indoor Biotechnologies Limited at a higher scale. Next, we'll have Ross Yaram, who is our business relationship associate, who will be speaking to our environmental testing suite. Ross will be providing some technical specifications on the environmental testing suite, as well as applications. Finally, we'll have Dr. Maria Oliver, senior scientist at Indoor Biotechnologies Limited. Maria is going to be providing some in-depth discussion on our viral testing capabilities, including the standards that we're able to test to, as well as an example of a case study. I'm your moderator today, Beatty Sturgill, Business Development Manager here at Indoor Biotechnologies Incorporated, located in Charlottesville, Virginia. So to provide a little more structure today for our webinar, again, Hayley will be starting with the Indoor Biotechnologies Limited overview, where she'll be speaking to the products, analysis service, and contract research opportunities. Next, we'll move into Ross with the environmental testing suite, where he'll discuss safety and product efficacy testing, as well as a new aerosolization model that we are currently working on. And then we'll have Maria close us out with viral testing, where she'll speak to product testing for virucidal efficacy, as well as some contract research opportunities for virus projects. We'll close with a Q&A section. I ask that you please submit any questions using the Q&A feature in the Zoom toolbar. You can post questions there at any time during the webinar, and we'll get to as many as possible. As some of you are probably aware on the call, there's a big soccer game or football game here in an hour, so we're going to keep the webinar nice and tight so all of our UK and European counterparts can be sure to make that game. But with that, I think I'll turn it over to Hayley.
Thank you very much. Hello, everyone, and thank you for taking the time to join us today. My name is Hayley Mills, and I've been with Indoor Biotechnologies for just over 5 years now. So prior to this, I completed a master's in research and my PhD at Cardiff University. I was studying in inflammatory pathways which cause atherosclerosis, so a little bit different to allergy. Following my time in the lab, I decided I wanted to use my skills and knowledge that I'd gained during my studies and apply that in a customer-facing role. So initially, I joined the team as product and service specialist, where I was primary contact to our customers across Europe, helping them get the best out of our products and services. And at the beginning of this year, I took on the role of European business manager, where I now oversee the team here in the UK. So, as already been said, what I want to do today is just give you a quick overview of Indoor Biotechnologies in the UK, some background to the company, and a summary of the products and services we offer here. Following this, Ross and Maria will go into a little more detail around the unique facilities and capabilities we have here in the UK. So as many of you will know, Indoor Biotechnologies was founded by Dr. Martin Chapman in 1994. And the company has over 25 years experience specializing in allergy. Martin is based in our US sister company in Charlottesville, Virginia. Initially, InBio UK was actually set up primarily to distribute products across Europe. But around 10 years ago, the company expanded into a small laboratory facility, which enabled us to also offer some services as well. Over the last 10 years, we've expanded into a purpose-built office and laboratory facility, which you can see in the photos on the slides. And also in the last year, we've been able to expand even further and build a second environmental testing suite, which is the last picture, and take on some additional lab space for our tissue culture and viral testing services. So primarily our services are offered to customers across Europe, but our environmental testing suite and our viral testing capabilities can actually be utilised worldwide. Next slide, please. Just a quick overview of our products. Some of you may be familiar with these. So InBio offer a wide portfolio of products which are manufactured in our US company. Our purified allergens are validated under an ISO 9001 certified quality management system and comprise of natural, recombinant, low-tox, and biotinylated allergens. But also we have some rhinovirus proteins and more recently a suite of SARS-CoV-2 proteins. We also offer allergen immunoassays with our new ELISA 2.0 kit, providing all the reagents needed to perform the assay in just 2 hours, and our multiplex Maria assay for simultaneous measurements of allergens from just 1 sample. So along with our dust collection devices, these products allow us to provide a suite of allergen testing services as well as contract research. Next slide, please. Next, I'm just going to go through our service offerings, and we're going to start with our analysis service. So utilising our ELISA and Maria assays, we can offer allergen testing in our lab in Cardiff, as well as with the guys in the US. This can range from testing environmental samples, which could be from people's homes or places of work, things like dust mite, animal or pollen allergens, right through to testing allergens in food samples. So our lab is ISO 17025 compliant, but we can also offer endotoxin, enzyme and cytokine quantification as well. So this testing service has enabled us to be part of clinical trials, and to date we've been involved in 3 trials in the UK, where we've measured allergens in environmental static dust samples using our Maria assay. This year we're also taking part in a new trial where we'll be analysing both static samples and airborne samples for indoor and food allergens using our Maria and Maria for food assays. So that's going to be really exciting. So static samples will be collected using our dust stream collector. Some of you may be familiar. It fits on the end of a vacuum cleaner and collects static samples into a filter. And our airborne samples will be collected using our Apollo sampler, which can be seen in the picture on the right-hand side of the slide. So the Apollo is a device that we've been working on internally over the last year or two. It's a plug-in device which pulls air through the front grille there, that black grille on the front, onto a filter. So this filter can be easily removed and analysed for allergens then. So we designed the device to be relatively small. You can't really tell the scale of the product there, but the face is about 15 by 15 centimetres, quiet so that it can be run in the house over potentially long periods of time without an annoying buzzing sound going on in the background, and cost effective, which would enable large scale studies to be undertaken as well. The initial data from the Apollo sampler suggest high efficiency to collect allergens, and we hope that the data collected in this trial will further support its use as a novel airborne sampler. So for future studies, we're also planning to investigate the ability of the device to collect bacteria and fungi. So lots happening around this sampler, and keep an eye out for any updates on that. Next slide, please. That takes me to my final slide on our contract research capabilities. Utilising our expertise in allergy, we offer projects designed to fit customers' needs. Our collaborative approach is flexible, and we operate a stop-go approach on larger projects which may involve multiple stages. So if the initial phases are not successful and the project's not feasible, subsequent phases won't go ahead and be charged, won't have any financial impact on the customer. So examples of the projects we've been involved in are custom assay development, and this usually involves purifying an allergen or another type of protein, raising antibodies and developing and validating an ELISA or a Maria assay. We also have Western blotting capabilities in-house, and as mentioned, and we'll go into more detail from Maria, we offer virucidal efficacy testing. Finally, we also provide efficacy testing of allergen removal claims, and these projects are designed to support customers from product development, so maybe deciding what formulation to use, right through to claims verification, providing the data to back up claims of removed 90% of allergens, for example. So products can include sprays. These could be surface cleaners or products sprayed onto soft furnishings, for example. Wipes, mattressing casings and fabrics, which a lot of allergy sufferers use in the home, air purifiers and vacuum cleaners. So the latter two, air purifiers and vacuum cleaners, these would be tested in our environmental testing suite. And that leads me nicely onto the end of my section and onto Ross, who's going to go into a bit more detail about the suite and the type of testing we offer within it.
Brilliant. Thanks, Hayley. Hi, everyone. Thanks for joining us today. So I'm Ross Sharon. I actually recently rejoined Indoor Biotechnologies here in Cardiff as a business relationship associate, having actually previously worked here as a research and development intern during my degree in biotechnology, also here at Cardiff University. So it's great to be back. And previously, my experience stems from the UK Food Standards Agency. So whilst I was there, I acted as manager of the Food Allergy and Tolerance Research Programme and also acted as their senior allergen risk assessor. So overall, this has given me quite a good understanding of the private and public sector in a regulatory environment in particular. And I'm now very excited to be back and working in a business development role, but very much still with my scientist hat on. So it's great to be back. So just a general overview and introduction to this section. So allergies overall have gotten quite a lot of attention over the past two decades in particular, and for good reason as well. So it's thought that over 150 million Europeans suffer from allergies, and there are predictions that half of the EU population will actually be affected by 2025, which is quite scary if you think about it. It's not that far away. So I mean, worldwide, it's even predicted that 4 billion people will suffer from some form of allergy by 2050. Obviously, these are quite stark statistics, and thus it's important to develop strategies to help manage the condition and to improve the quality of life for those with allergies by managing the level of allergens that they're exposed to, by aiding the ease of allergen avoidance, essentially. So nowadays, we spend the majority of our time indoors, either at home or in the office, which for many of us at the moment, as you know, is very much one and the same thing. And so studies have shown various levels and types of triggers of allergens in the indoor environment, either in dust or in particular in the air. So you'll see on this diagram a few examples of what these could be. And if you can see in the middle there, you'll even spot food allergens up there. And you'd be surprised actually where these can end up in our homes and indoor environments. Next slide, please. So to help improve the situation for allergic individuals, avoidance is the best course of action currently, but it's not always as easy as it sounds. However, innovative solutions and products can drastically help improve the situation and reduce the burden on the individuals. So there are many products that claim to help reduce or even deactivate allergens in these environments, but robust strategies and experimental design are required to provide efficacy on these claims and to ensure that these types of products actually help allergic individuals and do what they say they do, what they claim. So this is where our unique testing capabilities come in. So we at Indoor Biotechnologies can perform a range of testing that can validate allergen removal claims and to ultimately help ensure that products and avoidance techniques do actually improve the health and quality of life for those with allergies and other atopic conditions such as asthma. So with us here in Cardiff, in addition to our wide range of analysis and service work that Hayley covered previously, we've also built two complementary environmental testing suites, which can be utilized for such product testing work, but with the ability to customize many aspects depending on the application. So we're really excited about these. Next slide, please. So just to demonstrate this, I thought the best way to do this is actually to show you a video that we've created of our environmental testing suites in action, and also you'll see members of our team here in Cardiff and scientists performing these various pieces of work. And so I'll play this video now. Brilliant. So just to quickly recap on the video. So at our facilities here in Cardiff, we have 2 complementary environmental testing suites available, each representing differently sized and shaped rooms that can be found in the home or office. In the smaller suite, we can perform smaller scale developmental work, which can then be optimized and upscaled in our larger suite. So on the right, you can see some schematics for our smaller one, on the left, for our larger environmental testing suite. So both of these contain a dry and a wet room to mimic a small bedroom / living area and bathroom, respectively. Each room has independent HEPA filtered air and temperature control on the outside. And the dry room has been designed to AHAM AC1 standards, and our larger, newer environmental testing suite dry room has an approximate volume of 28 meters cubed. So quite a capacity in the larger one. The suite is primarily used to test the safety and efficacy of home and personal care products, as Haley mentioned earlier, including air purification devices, cleaning products, vacuum cleaners on carpets and textiles. The facility supports all ranges of product development, from research and development, formulation testing, and validation of end product claims, again, which I mentioned previously. On top of this, and what's unique to us here, is our comprehensive allergen testing, which we can provide on site by our expert scientists using our quality immunoassay platforms. And so we really can provide that end-to-end service. Next slide, please. So just a bit more detail about our testing capabilities that I was mentioning. So the ETS has expanded these capabilities, and we're now not just limited to working with allergens also, which Maria will go on to in a bit too. So in terms of safety testing, we can perform, for example, simulated use studies to monitor the level of potentially allergenic or hazardous compounds a consumer may be exposed to from use of the product. We can also, in terms of efficacy testing, we can provide efficacy testing to validate claims on a variety of different products. And we also have aerosolization models for dust-containing allergens in the works. Which enables us to provide efficacy testing on products aimed at reducing allergen levels in the air, so thinking air purifier devices. We can also validate these allergen claims again by coupling the experiments run in the testing suite with our Maria technology. And what this allows us to do is to multiplex and measure levels for several allergens all in one test. So for example, we can test for dust mites, animals, pollens, molds, and even many food allergens, which we recently added to our portfolio. And lastly, a new avenue for us in development is the aerosolization of bacteriophage as a model to study the efficacy of products aimed at reducing pathogenic virus viability. So this is a new capability for us here at InBio Biotechnologies, and we're in the early optimization phases for this work, but very excited about its potential applications, particularly with everything that's going on at the moment. Our resident virus expert and senior scientist, Maria, will touch on this and other viral testing capabilities now. So I'll hand over to Maria.
Maria, sorry, you're on mute.
Thanks, Haley. So yeah, thanks very much, Ross, and thanks everyone for joining us here today. I'm the senior scientist here at InBio Biotechnologies in Cardiff, and my job is basically to oversee the routine analysis and the research and development and the contract research work that happens over here. I've been with the company for about 5 years now, over which time the UK lab's grown both in size as well as capabilities. So to begin my section, I'm just going to give you a better understanding of our viral testing capabilities, but also a little bit of background into why we actually started doing viral testing in the first place. It's not the most obvious leap to jump from allergen testing to viral testing. So I actually have a PhD in viral immunology, and before I started working with IBL, I was actually working as a postdoc at Cardiff University, where I was researching CMV for several years. And so once the coronavirus pandemic hit back last year, we sort of thought that there was potential for our lab work and the contract research work to take on a new angle. And as the great man himself supposedly once said, in the midst of every crisis lies great opportunity. So we took this on board and we had a lot of internal discussions. And basically we thought that we could come up with some options for what we might be able to offer people and how we might be able to help out during the pandemic. And the two solutions that we thought we might be able to offer were suspension and surface testing in accordance with specific technical standards. And I'll explain those in a bit more detail in a minute. And these would be using to test viral efficacy of different products. And also we thought that there may be scope to improve our customized testing methods, so our contract research type approach. So consequently, using our experiences in viral research and quite a lot of our entrepreneurial spirit, we decided to set up a brand new tissue culture suite here in Cardiff. So next slide, please, Vicky. Okay, so a bit like Ross, as a just a kind of introduction to what we've got here, and again, a bit of an insight so you can actually see what the facilities are and our scientists working. And we've got a bit of a quick video just to show you. So if you could play, please, Vicky. Okay, so hopefully that gives you a little bit of insight on what we can do. So I'm just going to go into a bit more detail. So as you saw in the video, the tissue culture suite is set up in accordance with Biosafety Level Category 2. And this means that there are actually quite a lot of viruses that can be tested under these safety levels. And these include vaccinia virus, as well as human coronavirus 229E. The reason that I mentioned these two specifically is that human coronavirus 229E belongs to the same family as SARS-CoV-2, but it's far less harmful as it's actually one of the many viruses that causes common cold symptoms in people. So it's a lot safer to use, but because it is a closely related member of the coronavirus family, it can be used as a representative virus for viral testing experiments. And the reason that I mentioned vaccinia virus, this is an important one because it's actually considered as a reference virus for all envelope viruses as set out in the EN and the ASTM standards. Some of you may be familiar with these standards and some of you may not be. So if we move on to the next slide, please, BT, I'm just going to go into a little bit more detail about what these are and why they're important. So obviously with the hype of the pandemic, lots of different products coming to the market, carrying claims of antiviral properties. But to legally be able to claim that a product is actually antiviral or virucidal, it has to be tested against one of these standards. So EN 14476 and EN 16777 for use in Europe. And for use in America, they must be tested against ASTM E1052 and E1053. However, they are both recognised globally. They're quite familiar standards with this kind of work. So the EN standards are specific documents, very big documents in fact, that have been ratified by one of the 3 European standards organisations. Basically, in this huge document, they provide very specific and exact technical information for how a product has to be tested, as well as providing criteria that a product has to meet in order to claim virucidal properties. The ASTM standards also provide a very similar level of detail. There's just a slight few differences between the two. So if a company wanted to make a claim that, say, they had a surface disinfectant that had virucidal activity against all viruses, it would have to be tested according to the regulations against the viruses circled in the red. And these are poliovirus, adenovirus, and murine-norovirus. So obviously, to test the product against all these 3 viruses, it's a lot of work and involves, quite an in-depth analysis of the product. However, if they want to make the claim that it has virucidal activity against just envelope viruses, and the reason that's important, as most of you I'm sure are aware, is that SARS-CoV-2 is an envelope virus. So if the product works against an envelope virus, in this case, the standards quote to use vaccinia, which is also an envelope virus, then the company could make the claim that it would also be antiviral against SARS-CoV-2. So obviously, just by testing the product against this one virus versus all 3 would save a lot of time. It's much quicker and much more straightforward. So that's why they're important. Currently, we have vaccinia virus at our lab, but we're hoping that we will soon be expanding our portfolio to encompass the other 3 viruses as well. Okay, next slide, please. So in addition to the work we can provide that follows these standards described, we also aim to help clients with a more customized contract research projects. And we've been running custom research projects on an allergen basis for many, many years. So we're quite accustomed to doing these kind of projects, but we just thought we'd try and now offer this on a viral principle as well. So I thought the best way of showing you kind of what we are capable of doing here is to give you a really nice case study that we completed with a company called Sandila last year. So Sandila are the only European manufacturer of eco-friendly boards produced from waste paper fibres. So they describe themselves as kind of circular. So they get the boards, they recycle them and use them again. It's really kind of like a green approach to this kind of product. So they have many different types of boards, and they're used in a variety of different settings, including schools and offices. You can kind of see them set out in one of the pictures below here. They're used from small things such as pin boards to much larger scales, such as wall linings. So what they came to us for was basically they wanted to ask the question, how long are viruses, and in this case in particular SARS-CoV-2, viable on the surface of their materials that they manufacture? And the reason that they wanted to know this was so that they could then assess if these boards could be safely used in hub schools that were open during lockdown for children of key workers, or as partitions for social distancing in public or private businesses. So basically, they just kind of wanted to know, were these things going to be helping the virus live longer, or were they going to be useful in terms of the virus to survive on the surface? So if we go on to the next slide, give you a little bit of background to how we came up with this project. So the important thing to note about this project is that they weren't specifically asking, is our product antiviral? That's important. What they wanted to know simply was how long the virus was viable on the surface after a defined period. So consequently, there's no specific standards or protocols for this kind of work or on this kind of surface. So we had a bit of free rein to kind of come up with our own testing protocol. So due to SARS-CoV-2 requiring Biosafety Level 3, which we're obviously not set up for, we were in consultation with Sandila, and between us, we chose human coronavirus 229E as a representative virus. The slightly problematic thing with 229E is that titering it is actually quite difficult and it's very slow growing. It doesn't cause normal cell lysis like a lot of viruses do, so standard plaque assays can't be used. So instead, we had to basically optimize this another, it's called an indirect aminoperoxidase assay. And this uses HRP as a readout. So that took a little bit of tweaking, a little bit of optimizing, but once we got there, we'd grown up 229E, we'd established a method for measuring it. We then could proceed with the protocol. So Sandila sent us 4 different boards for testing, and these are shown in the middle picture. Hopefully you can see that they actually all very different compositions and textures, and they have very different properties. So obviously, with no direct protocol to follow, we kind of came up with our own protocol, and this involved depositing small droplets of media which contain 229E on the surface of the boards. The droplets were then left for defined periods of time. We then swabbed the boards with medical swabs to see if we could detect anything on the surface. So the swabs were then eluted and assessed for viral virus by this optimized IIP assay. And in the presence of 229E, following this assay, they can be identified by this brown positive HRP staining, which you can see in the bottom picture. So that's how you know if there's virus still alive. So on to the next slide, please, BT. Okay, so here's the results. So the first time point we looked at was 1 hour. So after 1 hour, we found that 3 of the boards had very low but still detectable levels of virus remaining on the surfaces. So these we then took forward for a longer time course, and this results are shown in the graph on the right. If you look at the 1 hour time point on the x-axis, you can see that there in the 3 boards, there's the K, the HD, and the M. They're the ones we're going to focus on for now. There is small amounts of virus still remaining on the surface. So the M board shown in red, that performed probably least well. You could still detect around 7% of the virus that was deposited. The K board, which is shown in blue, did pretty well with only roughly 2% of the starting amount of virus left. And the HD board, which is shown in green, has only about 1% of the starting virus remaining. So as I said, we took these out then for longer time courses, and we assessed them at 4 and 8 hours. And at both of those time points, all 3 boards performed really, really well, with just less than 1% of the original virus still remaining on the surface of the boards. We did actually extend this to 24 hours. It's not shown on the graph, but actually we didn't find any detectable virus on the surface after 24 hours. So these boards, performed really, really well, but there was another board, the FR board, which actually blew us away with how good it was. So we did the 1 hour test on this FR board, and we found no detectable virus at all after 1 hour. So rather than taking this for an extended time course, we actually made a shorter time course. We swabbed the boards after 30 minutes, 15 minutes, and we even did it 5 minutes post-application. And much to Sandila's pleasure, we couldn't detect any viable virus at these time points. So if you look closely at the graph, the FR data is plotted on there. It just performs so well that it kind of drops off at the face, almost at the zero hours there, you can see. So these results obviously were really good for Sandila, and what they then used was the information that we gave them to come up with their own marketing strategy. And they came up with what I think is a really good idea for the use of their boards at the height of the pandemic. And what they did was to design push panels, which you can see in the bottom pictures here, on swing doors in offices and in schools, so that people could use these instead of having to share door handles, which could potentially have been a source of contamination and spreading the virus. Safely, kind of in the knowledge that if somebody had somehow deposited virus on those push points, that within 5 minutes there would be no longer any viable virus left on there. So that's just an example of one of the sort of projects that we can run that are completely customised here in Cardiff. So on to the next slide. This is the last one for me. I just wanted to explain a little bit more about this new aerosolization model that we're hoping to get up and running very soon. So due to safety issues, obviously, with aerosolizing most viruses, and in particular SARS-CoV-2, we need to find an alternative method for assessing virucidal activity of products on aerosolized viruses, so such as like antiviral sprays or something that's supposed to be sprayed into the air, and can they denature or make the virus non-viable actually in the air itself. So this method uses bacteriophages, and the reason that this is considered a pretty good model is that bacteriophages display structural features similar to those of human and animal viruses, and there's multiple strains of bacteriophages that represent enveloped and non-enveloped viruses, and there's single-stranded, double-stranded, RNA and DNA phages, so many different sorts. Basically, they offer the unique benefit of requiring only biosafety level 1, and so that means we don't have to keep these confined to our tissue culture suite. It means that we can actually use them in our environmental testing suite for potentially assessing virucidal activity of aerosolized products. So we have currentally got one strain of these bacteriophages in our lab. We've got the MS2 strain. Just in the last week or so, we've just begun to do the propagation of the phage and its host. Disclaimer, this isn't my assay plates. I hope very soon it will be. But this is what you can actually see. So once you grow up the phages, they burst, they infect the E. coli and they burst them open, creating these lovely little holes on the plates of like these E. coli lawns. So we're hoping to move forward with this really soon. We're really excited about this as it is a brand new capability for us, and we're hoping that by combining our viral immunology expertise along with our environmental testing capabilities, that we'll be able to offer kind of this as a unique thing to customers on a contract research basis. So we're hoping to get this up and running really soon. So that's basically what's going on over here. With that, I will hand back to BT. Apologies about the mute. Has to happen, doesn't it, at some point?
Thanks, Maria, and thanks to Haley and Ross as well for your presentations there. So all of these products and services culminate into InBio's expertise in action, in which we use our proven scientific acumen to help find the best solutions for our clients. That, of course, includes the environmental testing suite to which Ross spoke, where we can test the safety and efficacy of products and procedures for allergen denaturing, removal, as well as barrier testing. Maria spoke to our viral testing capabilities, where we can use our expertise in viral immunology in our new state-of-the-art facilities that operate at Biosafety Level 2, as well as ISO 17025 compliance to help aid clients in establishing virucidal efficacy claims. Haley mentioned our portfolio of purified allergens and proteins, which also includes human rhinovirus, as well as SARS-CoV-2 proteins. We offer these in natural and recombinant expression systems, have a low endotoxin product line, and these are also manufactured under an ISO 9001 certified quality management system. We also have a comprehensive portfolio of immunoassays. We offer these in both testing kits as well as a service. That includes our ELISA 2.0, which are pre-coated plates with all the necessary reagents to run the assay in 2 hours, as well as our Maria technology, which is our multiplexing array that provides for the simultaneous measurement and quantification of multiple allergens from a single sample. Here in Charlottesville, Virginia, we have a mass spectrometry suite in which we offer standard services to our clients. That includes protein identification, protein profiling of complex samples, and intact mass. And this really provides a very powerful tool to users in wanting to characterize their samples better. All of these products and services help our clients achieve what we call research made real, where you're able to speak directly to InBio scientists who provide flexible and agile solutions for your product development and validation efforts. So with that, concludes our presentations, and we can move to our Q&A section. Again, please submit any questions you have using that Q&A button. You can post there, and we'll get through as many as we can. I'm going to stop the screen share here, and we'll move to some of these questions. Maria, I think this first one will be for you regarding viral testing. Do the EN and ASTM standards apply to aerosolized studies as well? Does the bacteriophage and aerosolizing models meet the EN and ASTM standards?
So yeah, that is a really interesting question. So the short answer, no. There are no actual EN standards for the aerosolization models. There are various different additional standards to the ones that I've mentioned. But again, they're very much like you can have a product that you could spray, but then it's tested by surface wiping. So there's no defined standard that you have to follow for an aerosolization model. And that's why, again, we're quite excited about the bacteriophage setup, because it does provide scope for us to be able to one, kind of guide the customers themselves, but also work with customers to answer the questions that they may have. So rather than being constrained by these particular standards, it actually gives us quite a large scope, many different options we could do with them. So that's yeah, basically no, there is no standard for aerosolization models per se.
Okay, great. No, that sounds good. I think in that same vein, to stay on topic here, could you tell me a little more about the MS2 bacteriophage and why you have chosen to use that strain first?
Yeah, so as I mentioned in my talk, there are lots of different strains of bacteriophages. So the MS2 is actually it's a non-enveloped bacteriophage. So people may say, well, you know, if you want to use it for a SARS-CoV-2 model, then why are you using a non-enveloped bacteriophage when, you know, SARS-CoV-2 has obviously an enveloped virus? Now, there are enveloped bacteriophages out there, and there's a strain, a particular strain called 5.6. It's quite difficult to get hold of here, as most people are aware that the general supplier for any kind of cell culture, any kind of bacteriophages, any kind of viruses, is the standard supplier is ATCC. They unfortunately don't have this cell line. There are other options, but it's far less easy to get hold of, basically. And at the moment, there are plenty of peer-reviewed papers in the literature out there that use MS2. So obviously it's well known in the literature, it's well known by people in the field, and it's generally accepted as a really good model. And in fact, envelope viruses or envelope bacteriophages are often considered to be less stable in the environment. They can be broken down a lot easier. So MS2, obviously not being enveloped, is potentially more stable. So this is almost kind of like worst case scenario type bacteriophage. So if your product worked against MS2, you could probably then assume that it would also work against the enveloped ones.
Okay, great, thank you. Haley, I've got a question here for you. To use the ETS, would you need to come on site, or can we arrange remotely?
I would say the majority, if not all, of our projects are actually arranged remotely. So, you know, we don't necessarily need somebody here in person. If a customer wanted to come and visit, maybe there was a special requirement where they would need to set a, you know, a product, for example, then that would be fine. But no, what we usually do is we would work with the customer on a project proposal. They would ship us, you know, a spray or, you know, an air purifier, whatever they were testing. And then we would just test that in accordance with the proposal and, you know, the manufacturer's instructions. So no, not necessarily. We can do it all remotely.
Great. I think this next question will apply to both the ETS and viral testing. Maybe we'll start with the ETS first. How long does it typically take to complete a project? So Haley, I don't know if you wanted to speak in terms of environmental testing suite.
So that can range quite a lot. So it depends on if we have sort of a standard methods. Some customers come to us and they have standard methods they want us to follow, and that means they're a little bit shorter maybe, because we don't have to come up with a proposal, we don't have to employ any sort of feasibility testing and that sort of thing, and also how many products they actually want to test. So I would say on average maybe anywhere between 2 to 3 weeks for, say, an air purifier, for example. And also in terms of scheduling, what would happen is once we'd agreed on a proposal and a method with the customer, we would then sort of schedule them into our, you know, ETS workflow, and that could be anywhere between, you know, a month or two. Sometimes we can turn them around a little bit quicker. It just depends what we have going on, but there's not a particularly long lead time. You know, you won't be waiting until next year or something. So I think we pride ourselves on being quite efficient and turning around things quickly. So hopefully we'll be able to work with the customer to fit in with their timelines as well.
Great, thanks, Haley. Maria, do you have any comments regarding that from a viral testing standpoint?
Yeah, similar to Haley. In fact, you know, it is project dependent. Again, we do obviously try and turn around these things pretty quickly. Something like the Sundila project that I told you about, because we were kind of going on a step-by-step basis. It was like, well, what happens after 1 hour? Then what happens after, you know, 8 hours? And then we went the other way with the FR board. So that was a number of weeks, just because that kind of the project just developed. But as Hayley said, if some people come to us with very specific questions that they want answering, then obviously, you can probably turn that around in a week or two. Again, it would depend on what viruses they wanted to be testing. Obviously, we aren't huge, so we can't have all the viruses being constantly grown at the same time. So some of them are frozen down in long-term storage. So it would depend on the turnaround time to get those back up and running. But we do have stocks, as I said, already here for the 229E and vaccinia virus. If somebody wanted something more newer, such as the adenovirus, obviously the lead times on that would be longer. That we'd have to take into account then getting that from a supplier, as well as propagating the host and the virus itself. So again, any sort of turnaround time to 1 and 2 weeks to a couple of months, I'd say.
Great, thank you. I have a question here. Does InBio offer a virus identification service? Maria, are you able?
Yeah, that's an interesting question. We haven't actually been asked that before. The short answer is no, we don't do that. I think probably to do that, I'm assuming it means from various samples, or from environmental samples maybe. I'm not quite sure. Identify viruses from what source. My hunch would be that the best way of doing that was kind of doing a PCR screen. We don't have that capability here, unfortunately. So right now, no, I'm afraid we don't offer that.
Alternatively, I was thinking as well, I know, again, we haven't done something like this, but potentially mass spec could work as well. Again, I think that would probably involve some protocol development, but that could possibly be an option as well, but nothing we do routinely anyway.
Yeah, no, I think that's exactly right, Hayley. I think that's something we could pursue with our mass spec capabilities here in Charlottesville. So, next question, can you briefly describe your design specifications for the Apollo sampler, flow rate, filters, etc.? Hayley, I don't know if you know those offhand, or if we may need to follow up with
yeah,
that.
I can't think of the flow rate off the top of my head. Maria might know, I'm not sure. But in addition to the things I mentioned, so keeping it pretty small and quiet so that it could blend into a bedroom, for example, because we had a sort of first prototype and a couple of people couldn't sleep with it on. It was sort of whirring and buzzing. So we've done some amendments to that, and it's quite effectively silent now. The filter is it's not something that's particularly widely used. I'm not entirely sure if I'm allowed to say what it is, because we're sort of under NDA with a company. It's a very specialized type of filter, something we've done a lot of research on in terms of capturing allergens. Maria, do you know the flow rate by any chance?
No, it's changed because, again, to make it quieter, we changed the fan. So initially, when we just designed, obviously the very first prototype, we just used fans that we could get off Amazon really easily, and they were just kind of normal computer fans that had a speed. So actually, the company that we worked with to get it quieter, they have sourced these particular, high power, long lasting fans. So off the top of my head, the flow rate's changed. But just a note on the filters, obviously, yeah, we can't say exactly what the filter material is itself, but what I will say is that we've done some comparable side-by-side testing with the kind of classic filters that you put into other air samplers. So we've done PTFE and we've done PFA, and they basically don't work anywhere near as well as our material. We've had the Apollos lined up side by side, sampling for exactly the same amount of time. And the allergen captured is far higher on our material, on our Apollo. So it is a kind of bespoke setup. It's very, very simple, but it works, kind of superior to what's already out there, I'd say.
Yeah, we can look into the flow rates. One of our scientists might know, or we've actually got a way to measure that in-house as well. So if you wanted to reach out and send us an email, we can provide that information after this.
Great, thank you. For the ETS, are you able to perform long-term exposure studies, 24 to 48 hours, etc.? Ross, I don't know.
Take that one.
Yeah.
So as of yet, we haven't run anything for quite that long. But again, we see no reason why that wouldn't be possible. and the actual facility set up to run for however long you would like. It would again depend on the actual application and also the type of sampler needed for depending on what you're looking to measure and how long that would be able to run. But again, there's ways around that. So what we would usually do in new scenarios would be to perform feasibility testing and then perhaps some optimization studies just to make sure that it's able to and viable to last and measure for that long. But overall, essentially, it's possible, yes.
Mm-hmm. That's good to know. And it sounds like, I mean, the feasibility studies benefits the client in the end, just to before developing the project too far.
Absolutely, yeah.
Ross, I think this may be another question for you here. For studies using the ETS, are we able to provide the dust, we being the customer, able to provide the dust or antigen extracts for efficacy testing? Are you able to characterize the dust?
So on the first point, absolutely. We'd be able to work with any material that you'd be able to provide us. Obviously, granted that its safety is okay for us to handle, of course, and we can arrange that. In terms of be able to characterize it, again, yes, we have to perform in-house analysis on it to detect the different levels, depending on what allergen profiles you're actually looking for. To run your tests, if you have particular allergens in mind, again, if it's animal, if it's dust mite, even if it's food, whatever, we're able to do that kind of characterization in-house. We also are able to create our own dust with known allergen levels. And again, we can produce that kind of stock dust for the test. So it's not necessarily needed to be provided from the customer if that's an issue. We're able to do that and characterize it in-house. And we would routinely do that to allow us to have that comparator between, say, if it was a air purifier, you want to know what's in the dust before then, so using the air purifier to see actually what's been taken out of the air and how effective that product is. So yes, is the short answer. We can be very flexible with if it's provided, but we can also create it.
Great, thank you. Maria, this will be a similar question. Are we able to select what viruses are used in a project? Are you able to purify specific viral proteins?
So yeah, in theory, definitely. As I said, we only have the vaccinia and 229E in our hands currently. We're hoping to get the other 3 that are listed on the EN and ASTM standards soon. But again, if you wanted to do something that was bespoke to you, if you're interested in a particular virus, then yeah, again, as long as it doesn't go above biosafety level category 2, then we'd be more than happy to have a go, propagate it and do the experiments according to the customer's needs. That's no problem. Sorry, what was the second part? The virus protein. Yeah, the virus proteins. We could do that. We already have done that to some extent. Obviously, with the US team, the allergen manufacturing team in the US, they already have, as Hayley mentioned in her presentation, we already have a lot of rhinovirus proteins, and we obviously have the SARS-CoV-2 proteins already purified. That would have to be done on a contract manufacturing kind of basis. But again, there's no reason that we couldn't do that. That would be obviously in conjunction with Sabina's team out in the US.
Yep. Great. We'd be happy to discuss that with anyone further. That's no problem. Well, I think that's about all the time we have for today. I'm going to pull up one last slide here. We'd just like to thank everyone for attending today's webinar. We really do appreciate everyone's time and you allowing us to present this information to you. We'll be following up with a webinar recording and other information. We'll email that out to all registrants to this webinar. But in the meantime, if you have any questions or comments, feel free to email myself, Beatty Sturgill, at bsturgill@inbio.com. Or you can check out our past webinars on our YouTube channel. I've included a link there. That includes a webinar on allergen variability and early introduction foods, as well as one